the Sustainability Subcommittee meeting for the Concord Middle School Building Project. It is April 29th at 12:04, 2020. We have a full agenda. The end goal in my mind is for us as a committee to develop recommendations that we can pass along to the full committee for the full committee's meeting tomorrow. So hopefully we can get through this today and take a vote and move the document along. But that's kind of the ultimate goal for this, for the next 55 minutes. Looking at the agenda here, we weren't quite able to turn around the minutes from Friday's meeting, and since I had to get this posted 48 hours in advance, I put it on there in case, but we don't have them yet. We will get those together. I know we're trying to keep up to date to minutes, but this was a quick turnaround here. So we're going to skip item number 2. Moving into number 3, Martine, if I can, I'm going to bring up on the screen. So coming out of the meeting on Friday, the subcommittee meeting on Friday, Martine shared this cost analysis that her team had done. And clearly there's a lot of work in here, Martine. If I could ask you to really give us the quick highlights. I mean, I think we've got a lot, we leverage some of this information in the document that we want to pass along to the full committee. So I don't want to spend a ton of details, a ton of time on these details, but if you could quickly go over this and also just focusing on option number 3 primarily, because that's the direction that the full committee has given to the design team at this point, Martine.
Matt, can you share the slides? We're just looking at the Word document right now.
Still looking at the Word document. Oh man.
You just have to go back to share and choose what you want.
Change what I'm sharing. All right.
Yeah.
Sorry, everyone. Hang on. I'm going to toggle between a lot of documents here. So this is going to be.
So while you do that, I can explain a little bit. So we had done it for every option. So now everybody is agreeing. We're just focusing on option 3, which seems to be the preferred option for the town. So everything I'm going to talk about, in terms of the process which we did this, was done on every option. The numbers are coming from both the PMC estimates and the Fogarty estimates. So we did it for both estimates as well. So that's why at the top there you see Fogarty, and Fogarty had really split the 4 options for each and every of the enhanced sustainability components. PMC had pretty much bundled them in one, all options in one. So that's why I wanted to make sure that those were all kind of compared and there for everybody to see. So what you're seeing here, first, the incremental cost. So what we did is incremental cost following some of the enhanced sustainability memo components. So the incremental cost for the net zero energy ready enclosure only with glazing A5, one is with glazing A5, one is with glazing A6. Glazing A5 is the higher end triple glazing cost. Glazing A6 is the one that's lighter and less expensive. So we thought it was important. At the time we were asked to do all these different options. So I wanted to make sure that we were doing it for both of those. And then we took, the next one is net zero energy enclosure with A5, which is the higher glazing cost. And then including, so basically this is the whole comprehensive cost of the enclosure, the electrical, and the HVAC system. We did one with the VRF. We did one with I'm sorry here. Yeah, we did one with the VRF with A5, with the glazing A5, and we did one with the VRF with the glazing A6. And then we did one with the ground source heat pump. And with the ground source heat pump, we only did A6. Ground source heat pumps are already higher in cost. So we did the lower end of the cost on the ground source heat pumps. The difference between A5 and A6 doesn't move the needle a lot for ground source heat pump because it's already got a high incremental cost. Then we did incremental cost of the passive house separately because that was its own as well in the memo. Then we included where we could the first cost savings. If you do a net zero enclosure, you do have a first cost savings on the HVAC system that can be sized smaller. So PMC had provided for that, so we did that. And then we included, in order to do a payback, you take the incremental cost and you basically divided by if you can go back just to that slide very quickly, Matt, the operational cost. So you account for how many years you're going to recuperate that incremental cost. So we did operational cost for a stretch code natural gas system and the operational cost savings over a stretch code all electric. So what these numbers show is a stretch code building at an EUI 56. And if you compare a net zero EUI 55 to a stretch code EUI 56, the net zero building, that net zero building that includes the enclosure, the electric, and the air source heat pumps, is gonna save you 103,000. If you compare a net zero ready building at EUI 25 to a stretch code all electric at EUI 50, then you're gonna save 168,000, whatever, I can't see it, 766. So those are your annual savings on your utility bills, and you basically look at how many years it's gonna take to recuperate those upfront costs that you have in black above. So if you go to the next slide, so we did paybacks basically comparing each of those scenarios to a natural, NG is for natural gas, to the natural gas stretch code and to the all electric stretch code. So if you go in option 3 and you look at the net zero enclosure with A5 and net zero enclosure with A6, you have a range of payback between 3.8 years and 7.2 years. So that's the payback on the EUI 25 when you put in the enclosure, the electrical, which includes the plug load and the additional sizing of the generator and a air source heat pump VRF system.
So Martine, quick question. Right, we're looking at 7.2 and 3.8. The 3.8 is for A6 compared to the all electric. If you were to run it with A5 versus the all electric, it would be somewhere above 3.8 but below 7.2. Is that right?
That is exactly, that is right. That is right. So we just did it so we would show a range. I mean, there's a lot of numbers there when you look at all the options there.
Yeah, and I'm just trying to foreshadow so there's a package of recommendations that I had put together that I sent out to the committee, and the committee will comment on in a couple minutes. But it includes A5, and so I think they'll be looking at not A6, so they'll be looking at if we compare it to a natural gas boiler, then the payback is 7.2, and if we move forward an all electric as the baseline, then it would be somewhat below 7.2, but not lower than, we'll say, 4 years.
Right.
Okay, thanks, Martine.
And while we're talking, I may be able to check what that is if you want.
Oh, okay, well, I won't expect real-time analysis, but great. So, and then you've got one more slide here, I think, right, Martine?
Yeah, this is all the details showing the what constitutes the enclosure A1 to A4, the triple glazing A5, the sort of the credit, you know, the savings between A5 and A6, etc. So those are all the detailed backup numbers that we use to calculate those numbers you see in the other two tables.
Great, great. Thank you, Martine. Do any committee members have any questions for Martine at this time? Okay, I am hearing no questions. So I'm not quite sure how to go about the next steps here. I mean, as I said, the goal is to get together to get consensus on a set of recommendations for the full committee is our next step here. Actually, let me follow my agenda. So does anyone on the committee have any high-level comments on the pricing that was shared last week at the full committee meeting?
Matt, this is Jared. I'm sorry, I was having audio questions. Quick question. I'm not a member, but
yeah, please go.
with those numbers that Martine just shared, they somewhat look familiar, but I don't remember seeing them. Are those new? Did we just put that analysis together, or is that something that we've shared before?
I mean, I'll say the subcommittee. So in the discussion this committee was having on Friday, Martine commented that she had done this analysis and she was approved to release the analysis. So we just saw it on Friday.
Okay.
I don't know, Martine, do you have more commentary to add to that?
I believe that 2 of the slides were shared last week for the SBC committee, but there wasn't. We didn't present them. I mean, they were flashed up for a few seconds. So I believe the subcommittee, the school building committee, the SBC, has 2 of those 3 slides. The only one they miss is the 3rd one because we just had sent the summary. So I'm not sure it's been shared beyond that.
Yeah, Friday seems like a month and a half ago, so it looked familiar, but I just wanted to confirm. Okay, thank you. Sorry.
Thanks, Jared. Okay. I mean, any broad questions on the conceptual pricing? We're going to dig into it in a moment here, but do any committee members have anything that they want that they really would like to get on the table?
That doesn't mean that lack of comment doesn't mean that we don't understand it or appreciate the good work here. So
Yeah.
Outstanding piece of work, and I really thought it was excellent. So
Yeah, I agree. I think, Martine, the level of detail is really helpful for us to understand. And I think, there's long been questions about what a lot of these sustainability measures are going to cost. And so it's nice to have this initial analysis. I think all of us, I don't want to speak for everyone, but I think that, all of us understand this is an early stage, but to be able to have an idea of what these things are going to cost, and especially the payback, really helps us put together a package to share with the full building committee to be able to say, these are the measures that are really critical to meeting the community's net zero goals. So it's nice to be able to take that goal and translate it to what does it actually mean in the details. What's the payback going to be? So thank you for doing all the analysis.
You're welcome. I'm glad it helped. Thank you.
I would add one little point. I'm really pleased that you did the gas analysis, because at the end of the day, you know, if people are suspicious of the cost of going all electric versus going gas, that suspicion and those feelings should be pretty much, you know, dealt with through this data. I mean, it's quite persuasive.
Mm-hmm.
Hey, Matt, this is Russ, and I concur as well. Great presentation, Martine. I just have some questions on heat pumps being used for heat. I don't know if now's the time to ask them, or if you want me to wait until we go into more detail, or.
Let's get those questions on the table now, Russ, because I think we're gonna start to dive into those details. But that's a big one. So let's start with that.
You know, I've seen heat pumps used for cooling. You know, they're out in the, you know, I've seen them used for cooling in data rooms and things like that. But I was always told heat pumps, I know, and the technology has changed as far as them being used for heat, but I was always told, like, is using heat pumps for heat, they're not really well in the Northeast with extreme cold. So are the heat pumps going to be our primary source of heat, or is it going to be a secondary source, or?
So in this case, the primary pump, the pumps are going to be the primary source of heat. And I want to clarify a little bit on some of the information you have on the heat pumps. Residential level heat pumps and some you know, some other earlier versions of VRF systems had a bad rep. You're absolutely right. They did not do well below 17 degrees Fahrenheit. And in the past, I would say in the past decade, they've highly improved to the point that the state is incentivizing them. And also there are different types of air source heat pumps and ground source heat pump systems. Those we would discuss mostly in schematic design, but to give you a little bit of an idea, when you build a 144,000 square foot school, you do not, they are not split system, and they are not the lower, kind of the smaller, not lower, but smaller sort of set of heat pumps, smaller type of system for heat pumps. There are some more developed commercial level VRF system that we call them VRF in the mechanical engineer world. And those are more attuned to larger commercial systems. So what we have here and what we're comparing here is those higher level heat pump systems that can be used for heating. And we're designing and installing those in a few other projects right now, and pricing those in a few. And we're not alone. They've been out there for about 4 to 5 years. I would say maybe a little more nationally and locally. So I hope I've answered some of your.
Just in the north. So in the Northeast, they have been proven to be successful. Are there like a lot of schools that use these?
Martine, if I can jump in just real quick, this is Mike Carroll. I'm currently doing a school, it's a phased construction, and it's using heat pumps with radiant panels along the perimeter, which I think is what we're looking at here. And it's been in operation for the last year without any issues as far as the heat pumps, even on when we had the cold spell in the middle of December. So anecdotal evidence that it's working right now. And we are implementing it right now for the whole building.
Right. Thank you, Mike. Yep. There's quite a few.
Okay. And like how many units would you? So you're talking like one large unit, or how many heat pumps are you talking for heat?
I don't have numbers right now.
Okay.
I'd have to go and talk to our mechanical engineer.
Okay. No.
Because it's very, very early.
Okay. No, thanks. And
so Russ, just on the Braintree project, we have about a dozen rooftop units that feed out to hundreds of VRF cassettes, if you will, inside each of the class. You know, there's 2 per classroom, and there's some in offices and things of that nature. This is a about 1,100 square student school. It's about 185,000 square feet. So a little bit larger than what we're looking at here. And I think as the systems get more efficient, you can probably reduce the numbers as well. But that's what we have at Braintree right now.
Okay. Oh, thank you, Mike.
When it comes down to, this is Kristen, when it comes down to that level of discussion and detail, you will be meeting one-on-one with our mechanical engineer to discuss all the trade-offs of the different system nuances, because there are a lot of nuances even when you go to VRF. So there's a lot of discussion. And we also frequently provide references from other projects who are doing it, so that you can talk to the facilities managers one-on-one yourself and get the story from them, how they're experiencing it.
Okay.
We're going to do energy modeling as well of those systems during schematic design of those different options.
Okay. All sounds good. Thank you. And the good thing I've heard about these units, they are very low on maintenance. And so one last question I haven't heard mentioned. What would we be using for the building hot water for occupants use? Is that just going to be an all electric hot water heaters, or?
Yep, they're going to be a probably point of use. We haven't finalized it, but it's going to be all electric for sure.
Yep. All right. That's all I have. Thanks, Matt.
Great. No, thanks, Ross. I think those are important questions, and it sounds like the design team, as we get further into the design process, will be in a better position to give you more information. Just thinking locally, I'm pretty sure that the Emerson umbrella, when they did their recent renovation, they went to an air source heat pump. I don't know if that's a good example. I don't know how it's working there. I guess as an outsider, that doesn't seem like a very efficient building. So I'd have some concerns about it, but I think that is the primary heating and cooling over at that new building or renovated building. Other questions like that from the committee? Okay, so what I have up is a 3-page document that I put together the other day based on the information that was released on Thursday at the Thursday full committee meeting. I don't expect, I know I'm scrolling quickly here. I'm just wanting to show you. I shared this with the committee earlier this week, or I guess late last night. In honesty, I sent an earlier draft, but then updates late last night. But again, where I'm going is I'd like us to have an open discussion about this document and hopefully approve it at the end of this meeting. I don't expect to go through and read all of this bullet by bullet. So we have some slides here that I am going to share instead, which might make it a little more digestible for the Zoom call here. Hopefully, are you looking at slides?
Yeah, we are. Can I just jump in before you start, Matt? Though we are looking at your presenter view, not that it matters greatly.
I don't know if I'm going to figure that one out, but okay.
But I just wanted to recap what Tim had said on our last meeting for anyone on this call, but wasn't here on Friday. So on Friday during our sustainability subcommittee meeting that was following the full building committee meeting, Tim Holtz charged us as a subcommittee with bringing a recommendation to the full committee for which options from the cost analysis, from the pricing, that are currently listed under enhanced sustainability that we think should be part of a package that is included in the base building. So that's what we're today, is to make that recommendation of here are the specifics from that costing for any folks from the public who are seeing things like A1, A2, A3. These are all details from the preliminary cost analysis that we saw as a full committee last week. And we're picking from that list to put together a package that we recommend for the building that's included in the design in order to meet the committee's goals and the community's goals for a net zero energy ready building.
Yeah, thank you for that setup, Kate. So and just to add to that, so what I have done is I took a stab at putting together a package for the committee here to react to, and this is you know, I guess I put together this package a little more unilaterally than I would like, but we had our, you know, we got this charge on Friday, and we have a full committee meeting tomorrow. So it was a pretty short window for us to turn this around. So that's for everyone. That's why it's kind of evolved the way it has. But you know, it doesn't mean that I think that Word document is perfect. It's a first attempt on my part to get something in front of the subcommittee here so that everyone can react to something rather than us having the time to kind of put together something from scratch. So that's the rationale there. Can you see the slides if I advance this here?
Yes.
All right. So I'm going to go through the incremental costs. These are some, I'm looking, I lost all my clocks here. These are a couple high levels. Kate, somebody just kind of buzzed in. Do I need to approve them, or can they just come in?
I got it.
Okay, thanks, Kate. These are some high-level bullet points, and I'm gonna show some more background. Again, a lot of this is going back to the document that included PMC and Fogarty's cost analysis that was released at the full committee meeting on Thursday last week. But from a sustainability subcommittee, so I'm putting forward that we as a committee commit to an all-electric design. So that's HVAC, which would drive us towards either an air source heat pump or a ground source heat pump system. As Martine articulated earlier, there are significant initial first costs with ground source heat pumps. So I would put forward that our recommendation right now would be to start with air source heat pumps, and so Russ, that gets quickly to your initial question there of certainly we need to make sure that you feel comfortable with that as a system and a strategy. But I guess I would suggest that we kind of start with that as our recommendation for now, and then we can have you work with the design team to get to a point where you're comfortable with that technology. Included with that HVAC recommendation would be a series of enclosure upgrades that there were a number of enclosure upgrades that the design team had priced out. I've kind of picked and chose a couple of them based on balancing costs and the goals of reducing the load and making this an efficient building. So that covers roof, wall, and foundation insulation. It covers better windows, but not the highest end windows that were costed out. It also includes air sealing, and then with an eye towards reducing other kind of energy loads, looking at improving the plug load controls. And then towards the bottom of the list, we just kind of get to some of the commissioning processes, the kind of, you know, there's two ends of it. There's the design side and making sure that we have a design that is on the path towards net zero energy ready. And then there's oversight and field quality control during the construction to make sure that we get the building that the design team has designed. And then passive house modeling, you know, I'm not saying that we commit to passive house certification at this point, but I think where we are in the process is we're trying to get our arms, or that's not, we're trying to get an understanding of all of the costs, the potential costs associated with this effort. And so I think we want to include everything for now. And then as we go through the process, we can figure out where we don't want to stretch and where we need to cut some costs. And the generator there, and I've got a question for you, Martine, when we get there. So let me just introduce this, and then I'll pause for questions. But this is a chart that Charlie had kindly pulled out based on the cost estimates released on Thursday of last week. So all of these A1, A2, M3, those all refer back to, and maybe I'll just show it real quickly so everyone recognizes it. If I can toggle quickly. Am I going to find it? Well, does anybody have any questions or comments or counter arguments to anything I've said so far as I search around here?
Matt, this is Mike Carroll. Just a quick question. It looks like you have A3 air sealing for $79,000, and then under the incremental packages, is that the same number? Is that counted twice there?
It is counted twice. Great question, Mike. So I mean, I guess this is where I want to have a discussion with the committee here. I mean, the initial package that is produced that was priced, and I'm sorry I'm not finding it. Maybe if I go, oh, I guess it's one of these. Okay, so this was Martine's PDF. This is the document that I'm referring to. Where is everyone seeing a PDF?
Yep.
So this was the document that was released last week in preparation for the meeting on Thursday. This is the pricing of the three options from Fogarty and PM plus C. And then we're looking mostly at option 3 right now. And if I scroll to the very bottom of this, let's see. I get to, and I'll make this bigger in a second, but I get to, you know, they priced septic and gymnasium and performance theater, and then there was a section on enhanced sustainability options. So I'm focusing right now on those. Let me make this bigger so hopefully people can actually see it. And so what I've done is I've pulled out like A1 is to go to 8 inches of roof insulation, and for concept 3, they give 204,000. So that's what's listed here. To answer Mike's question, so A3, I guess I just looked at 2 screens and you can only look at one. So let me go. That's the document that all of this was pulled from. And then to answer Mike's question, so they had for A3, they had as an enhancement 10% air sealing, increase in air sealing. And that gets, that's been priced at $79,000. what we don't know, and Martine, maybe this is a current question for you, is kind of what does 10% air sealing get us? Like where does that get us to? And so just in an effort of being super conservative in this first pass, I said, well, I think air sealing's really important. I think that we want to have a aggressive air sealing, and I suggest further down, one of the packages that I picked up, or one of the line items I picked up, is doing an air infiltration blower door testing at the end, and we want to get a good score there. So I'm gonna double the air sealing, and you know, I don't know if that gets us way too far. I just, you know, answering your question, Mike, I wanted to make sure that we were prioritizing air sealing and we were carrying enough money for it. Is $160,000 too much? Probably, but I guess I feel comfortable saying it's not going to be more than that to get us to where we want to be. And if we want to reduce that, then as we go through the design process, we can cut that down. Does that answer your question, Mike?
Yeah, I think that answers that. I think Martine might be able to expand. I thought the 10% got us down to the requirements that would meet passive house requirements. So if we're just being conservative there, that's fine. I think the other question that I would have is on the next one down, the plug load. I think that value, again, is that you're trying to extrapolate from the 75 to the 90%. Is that what you're doing?
Exactly. So I'll let Martine respond, but let me just say while we're on it, the same thing, right? So E1 was the enhancement, and it was going from 50% to 75% of the plugs. I guess my thinking was, well, do we want to stop at 75? You know, we probably don't want to go to 100 because there's some stuff that's got to run all the time, refrigerators and stuff, but maybe we want to go to 90%. And so I just took this and extrapolated out and said, okay, it's going to cost another, you know, $40,000 to get us there. So all total, you know, this is summing up both of those, and it's saying $100,000 on plug load controls. Is that too much? I mean, maybe, but again, we're really early on in conceptual pricing. But Martine, can you answer about like how much does the 10% get us towards air sealing?
So the base of the project has to be at 0.25 CFM per square foot at 75 PA because of stretch code. So we have to get there anyway. The 10%, I believe, I'd have to go back and check the memo, but Kristen, I don't know if you can double check that, but the 10% was our understanding that we could get to the passive house with that extra 10%. I think it's feedback we had gotten from Stephen Winter Associates. Now, I have to say though, that without the passive house reviewer overseeing this 10%, we feel that achieving 0.1 to 0.15 is going to happen with that 10%. I'm confident that we can get to the 0.1. And another big component to achieving that number is the building enclosure commissioning. So that's a big, having building enclosure commissioning and having a good building enclosure commissioning agent is key to get to there. And they support writing the specification for building enclosure commissioning in which we would put that criteria. The other thing I wanted to bring up about commissioning actually is the project is planned to have enhanced commissioning. That's my understanding. The base project is LEED Silver certifiable, and that includes enhanced commissioning. So I just wanted to bring that up as a comment, that it is my understanding that enhanced commissioning is there.
Okay, great.
Yeah. So that 80,000, I think, well, you know, I don't know if you meant that if you add in there, your thought was, your intent was that there would be a passive house reviewer fee into that 80,000?
No, that's carried under a separate line. That's carried, I mean, it's a question to you, but I guess I'm assuming that review and commissioning is covered in this 170,000 for the soft costs.
Hey, Matt, I've got a quick question on the 170
Yep.
and on the 80. Yeah, I hear the comments about, how this is going to get us close, the funding that's there. I guess my question has to do with compression testing. Does the 80, could you go back one?
Yep.
Does the 80 include compression testing during construction that would enable us to verify that we're at 0.08? I think finding out at the end of the project through blower door testing that we got a certain number is that's a good thing. But I think what we want to do is ensure that the during construction cycle testing is factored into this bidding thing somewhere so that we're sure to get it. Now I don't know how that's done here, whether it's in commissioning or what it's in, but we got to be sure it's in there.
Yep.
Is that fair?
Yeah, that's very good, Charlie. That's a good comment for sure. The commissioning does include some testing, but I think what you're referring to here is commissioning process does not do a mid-construction blower door test. That is possible to do. That is possible to add on, and I would say that would definitely fall into the scope of what you're trying to, I think, achieve in that 80,000.
Okay. Yeah, I mean, I guess what I'm hearing, Martine, is that you think the first 10% will get us to 0.1 to 0.15.
Yes.
Maybe not necessarily, you feel less willing to, to state that it'll get us to the 0.08 necessarily. And that there is also other kind of commissioning and efforts that would be required to get us down to the 0.08. So, I mean, unless, I don't know, Mike, I guess I look to you to kind of where we are with pricing here, but it feels to me like we need some extra. Is doubling it might be a little high, but at this point, like if we put $40,000 or $80,000, that doesn't feel like that makes a big difference.
Yeah, I think just from my perspective, what we're saying is that first 10% is that 80 grand. That's getting you down, that 10, that 0.1 per, on the 0.1 CFM. And I think as you're getting lower and lower and lower, you're paying a lot more per, for every 1/10 of a CFM that you're getting. So I think if it's 80 to get us that first 10, it might be, 200 to get us the second 10. Percent if you want, it's just that large diminishing returns.
Yep.
I don't know where that break point is.
Right. And so I think that's a discussion that we can have as we get further into the design of, like, maybe we don't want to pay that second 80, but
of course the problem is if you get to the end of the project and you find out that you're well above the goal, the CFM goal, then you're not going to be able to do anything about it. So that's the trade-off here, is getting some certainty through your quality control that you did what you intended to do. And if you want to take the risk of not hitting that goal, because it's things like that happen in these big projects, if we want to take that risk, that's something that we kind of have to decide to take as a group.
I think to that point, Charlie, we talked the blower door, but there's also individual window unit testing, curtain wall testing, wall testing that we can do in a quality control. And I think early on in the process here, we had talked about if we were going to get to that level of testing and assurance, that might sway the discussion that we haven't had yet on 149 versus 149A, and having a CM on board working with us rather than a GC just trying to get the job done. And that could have some serious cost implications. I think we're doing suggesting a 5% premium right now to go to that level.
So can I make a comment? Just, I mean, I can see the committee's, intent to mitigate the risk, really, right? By adding that extra cost and potentially extra testing. On the other hand, we did a project, that's why I brought up the enclosure commissioning. We did a project that wasn't net zero, but where we did an enhanced sustainability enclosure for many reasons. They may be shifting to all electric in 5 or 10 years. It was a GC-based project, very good GC. So and again, we were lucky in a way that the process ended up with a good GC. And we ended up, but the key was putting the requirement for the blower door test and having a really good building enclosure commissioning agent. And the combination of those two led to a below 0.1 CFM test. But that wasn't the goal for the project. We just got a super good enclosure built with a great commissioning process and a positive testing result. So it's doable. But in this case, if you absolutely want it, then maybe you put that contingency. I'm not sure that it is, Mike, that it's necessary, needed to be associated to 149A to a CM. I mean, I would keep those discussions separate. I think if we plan for it, if it's in the specs and everything, I think it could still be done with a GC.
I guess my comment is not to write it in that it has to be, it has to be kind of drawn in the sand and with cement. It's just that I think we have to be sure that we have the resources available to get this done right. We don't want to get caught and say, well, we weren't able to do that testing because it wasn't included. So if you're saying that we have reasonable flexibility here, then I'm okay with that. And I don't want all this, additional costs if we can avoid it. But, I think we've got to make sure that we can get it done.
Yeah, I think as long as we own the testing and the building, that's your lower kind of, ladder spectrum, the owning the testing and the building enclosure commissioning, and then the 10%. And then the next step is having the passive house reviewer there to follow through in addition to all of those. That would be the next step to further ensure the 0.08. I'm sorry.
Great. Well, if I can move us along, we'll return to that line item when we do the final kind of recommendations here. But so everyone can kind of mull on that while we move along here. I guess I skipped over the big one. The big at the top here, the switch from natural gas boiler to an air source heat pump saves $1 million in initial costs. So that kind of offsets a lot of these costs. I did include, I guess just to follow down the list here, good windows. There is an adjustment of almost $100,000 for downsizing the equipment. This is because of the higher insulation values. There's the plug load that we included. And then Martine, I put, this one's on here. Is this a additional cost that we incur by going to, my understanding from the cost estimating document is that in going from a natural gas boiler to an all electric HVAC, we kind of have to increase the size of the generator. And there's obviously a cost associated with that. Is that?
Yeah, so, yes, if you compare an all electric to an all electric, then you don't have that incremental cost. if you have an all-electric building, your generator needs to support sort of a minimum heating load in the case there's a power outage in the middle of the winter during a, storm or what have you. And so on a typical project with natural gas, we'll have a generator that will support safety and a certain set of equipment that you don't want to it to be turned off, like refrigerators and that type of stuff. When you move to an all-electric, you add the heating load to that, and it grows the generator. And so I saw a note on your previous slide about the sizing. I would say that as we go through the schematic design, we fine tune a lot of the design and the design of the building and the design of the equipment. Then that generator additional cost would probably get fine tuned somewhat. But that's what that number is there. Right. And so if you compare, again, if you compare to an all-electric base case, then you would not specifically have that. But I did include it in our numbers, though, because the estimators had it.
Okay, yeah. So I guess that's why. So I included it here. I mean, I guess two comments. I would, my hope is that we'd build an efficient building, and so because of that, we'd be able to the mechanical systems would be smaller, the loads that needed to be satisfied would be smaller, and we could maybe reduce the generator. So hopefully that cost comes down. In reference to what the baseline is, if it's getting compared to an all-electric baseline, then we'd also lose this $1 million at the top too, right, Martine?
Yes, exactly.
Right. So when you add those two up, it's a net of whatever, $500,000,
right,
$600,000. Okay.
Right.
Thank you for that clarification, Martine. We talked about these kind of two adders where I was just using the numbers that had been previously cost estimated and adding a little bit more, and maybe that's too much extra padding. But I guess, and then there's certification costs and additional soft cost support, which I'll show in more detail of what this breakdown of 170,000 is in a moment. But all total, this adds up to a little less than $1 million. And I guess, I'll say early on, my hope is that as we go through design, this number can come down. But from my perspective, I feel like that seems like a reasonable number for this project, and given the town's goals and commitments to kind of carry for now. So let me get through a couple more slides, and then we're starting to run against time here, but then we'll open it up to the committee for discussion. So Martine went through the payback, but here we've got the business as usual with an EUI of 56, and we're targeting an EUI of 25, and highlighting that this is by improving the efficiency, we're reducing the loads of the project, and so we've got a smaller circle on the right here because we've got just less heating and cooling that we need to use in order to satisfy the loads of the project. Here's the commissioning and testing. So this is that $170,000 line item. This is from a memo. This is not included in that pricing spreadsheet because this is coming from, but this is a memo that SMMA released last week. So SMMA proposed $15,000 as a line item for the whole building blower door testing. That's to check that the project has achieved that air tightness metric that we were discussing earlier. And then they've also have this this $65,000 for kind of design review. So Martine, a question to you. Within this breakdown, there was $50,000 for construction review and testing. And I guess I interpret this to mean this is the line item, and this is the kind of forecasted cost of what it would entail to do that enhanced enclosure commissioning, as well as any kind of mock-up air testing done through construction in order to ensure that we do well on this final whole building test that's going to cost an additional $15,000. Is that $50,000 cover it?
That's my understanding.
Okay. And then just so we're all on the same page.
Matt, if I can just probably, I don't know that those numbers ever came from the estimators, and I don't see enhanced commissioning, extending the enhanced commissioning. So I think that those numbers are maybe a little low.
I guess you're right. They did not come. So those came from SMMA, and I'm just trying to use the numbers that we have seen. So
Mike, this is what we got from, we discussed this a few months ago. This is what we got from Steve Winter Associates for the additional, that's beyond the lead equivalent enhanced commissioning. That's their review. So what you have there, yeah. So that commissioning that you have there, that's the lead V4, that's the enhanced commissioning we have in the project. We're supposed to have in the project, because this project is planned to be lead V4 silver with MEP and building enclosure commissioning. The $50,000 that Matt is showing is in addition to this, as my understanding.
Yeah, I'm gonna try and
Kristen
toggle here.
Yeah. Hold on just a sec. Kristen had to leave, unfortunately, so I may have to go back with her. Oh, it's not magnesium, it's your math class.
So this is where I'm pulling these numbers from. This is, if I scroll to the top, sorry to make people dizzy. So this is the memorandum dated April 13th from SMMA, giving guidance to the cost estimators. And if I scroll all the way down to the bottom, it talks about the mechanical systems and the enclosure upgrades and the electrical. And then as I get to the bottom, almost there, certification and soft costs for enhanced sustainability. So no action for the estimating team, but it says $70,000 for lead, $15,000 for the blower door testing, which I've picked up. The net zero energy certification is another 15, so I left that one off. But then there's the $65,000 for review, the $50,000 for construction and enhanced enclosure commissioning and testing, and then there's another $40,000 for the registration and certification fees. So that's what
the point is that the 170 is incremental to the 200. The 200 commissioning is really a separate line.
Right, in addition to, yep.
In addition, and it goes in our column for sustainability.
Right. And I guess my question to, I don't know if this is to Martine or Mike, but right, so the cost estimating is carrying 200,000. I don't have a good concept of what that gets us. I mean, Martine, I guess I hear you're saying baseline is energy stretch code and LEED silver certifiable. Right. So maybe that is enough enhanced commissioning. But I think that's one thing we'll wanna dig into as we move along here. That is this $200,000 enough? I guess right now we're based on the package that I have here. We're saying the total commissioning is $250,000.
Well,
that's what I'm saying, Mark. Matt, sorry. I just think I don't know that I would get tied to that $50,000 number. If we end up having a commissioning agent out, let's say during the construction of the skin of the building twice a week for 10 weeks, that's $50,000 there just for site visits.
Yep. Oh, what did I do here? Screen sharing stopped. I did something. Sorry.
Let's go back to the 170 page.
Right, I hear you, Mike. I don't think we need that much. It's not going to be twice a week for months on end. So I think that's those are.
Can we simplify it by saying the 50,000 is the extra? It's not twice a week, but I know it's extra observation and from the passive house reviewer to make sure and working with the trades to make sure that they're doing the taping right, and that for these specific details that do make the difference between that 10%, and that point to get to that 0.08. That's what the information we got from Lois and Steve Winter Associates when we looked at and assessed that 50,000 a few months ago.
Yep.
So
yep.
Could we say that the $200,000 is the lead V4 silver commissioning, and the 50,000 is that extra passive house commissioning? Could we? I'm just making a suggestion here. You could take it.
Yeah, that I guess is how it's set up right now, Martine. And so I agree with your recommendation. And I think, certainly, Mike, we can go back and review those numbers and see if that's the right number. But in putting this together, I want to use the current numbers that have been released. So.
Yeah, and I agree. I think the 200,000 should be sufficient for the base. I just think that with the amount of additional window testing, the amount of additional site visits, everything, I just feel that we're going to be spending a lot more to get to that passive house level.
Okay, so.
And that doesn't include the change orders when that commissioning agent tells the guy who's taping, you're not doing it right, you have to do it this way.
No, actually, Mike, the whole process does not bring change orders. They talk before he tapes. They talk before they tape.
If it's chapter 149, if it's not in the spec, then it's a change order. That's why going to that level might push you to chapter 149A.
But then the process needs that 170 as a design review. So the design review, that part, that 65,000 then may be required if we don't want to have change orders. So my understanding from Steve Winter Associates is that there aren't change orders. Our details are made, to meet quite a stringent level of air sealing, and then they come and they make sure that it's built right. So it's a little bit of an extra, but it shouldn't create change orders.
I hate to say this, but is there any reason why we can't leave the 170 for now and come back to it as we sort out the relationship between these two processes at a later time? Seems like we're getting down into the really into the weeds here.
I think you're right, Charlie. I think that's all we can do at this point is use the numbers that are out there, and then we can investigate and kind of follow up on these numbers. So, okay, we're 7 minutes over. I want to be respectful of people's times and the amount of Zoom meetings everybody's got, but I do really want to get to hopefully a point where this subcommittee can make a recommendation to the full committee for tomorrow's meeting. So I guess the slides I just showed are the summary of this. I know that not everyone in the public has seen this document, but this will get posted after this meeting. Hopefully the members of the subcommittee have had enough time to review this. So I go through and just laying out the insulation, taking everything on those slides that I just showed you, adding some additional commentary about how we wouldn't recommend costs, that window upgrades that would include result in a $3 million cost addition. Notes about ground source heat pumps and how we don't necessarily need to commit to that right now, so we don't want to pick up those costs, that we feel like it can be done with air source heat pumps. My generator comment, I rounded a bunch of these numbers. I rounded up or down, depending. I rounded up if it was an additional cost, and down if it were a, so you'll see the numbers might look a little bit different, but we don't need to carry it out to the $50 level here. And then I broke these down to design review, commissioning, and the certification. And so we can take those in chunks as we go through the process here, but it all wraps up into this number here. So you can see my total number is a little different based on my rounding, but we'll call it for the big highlights. It's $930,000 would get us a strong package. This would put us on the path to passive house certification. Now, certainly the committee can decide that we don't want to go to that full extent, and there would be some savings in a couple areas. I mean, I've been advocating from the beginning for passive house, not because I like certifications, but I think it's the best way to get to the efficient project that is one of the goals of the project. So, but there are lots of areas in which I think these costs can come down just through natural process of bidding, and then there's also some savings that we can take if the full committee deems that necessary. So with that, I guess I'd like to open it up to the full committee and get any feedback or comments on this Word document, and certainly any edits or changes that folks would like to make. Russ, Frank?
Sounds like a great idea.
Okay. Thank you, Russ. Charlie or Kate or Frank?
Yeah, yes.
I'm on board. I think this is, perfect.
Yeah, I mean, I think this is great, Matt. I mean, thank you for putting the time into putting this first pass for us, but I think it really aligns with Martine's packages that she put together for the cost estimating. So that was really helpful to be able to see those side by side. And I think it really captures, in great alignment with the costing that we've seen for all of the elements of the building. Like, these are the things that we need in the, and I don't know if this is the right way to say it, but from my perspective, like, these are elements, these, A1, that whole list of this package needs to be included in the base building, as things that we're not going to value engineer out, so that we'll ensure that we're meeting our sustainability goals that the community asked us for at town meeting and are in our project charter. So I think this is great, and I'd be happy to make a motion. I don't know, Matt, if you want to take any public comments at this point. I've seen a couple hands pop up.
Yeah,
so,
let's thank you, Robert. What's that, Charlie?
Yeah, Kate said it extremely well, that this is a package. This stuff can't be put up, to be value engineered. The stuff all works together. And I would just add that when we started this process, whenever we got together initially as a committee and way back in town meeting, this was the vision. This was exactly what the vision was to get to a very competitive EUI and use electric heat and go with a highly efficient building, and you know, our thought at that time was that it would cost about 1%. So I think that, you know, if you were to summarize where we're at with this, I think we're exactly where we wanted to be. I don't see any surprises in this, and I think it's all good. To be tuned, of course, but it's really all good.
Great, thank you, Charlie. Let's open it up for public comments. It's 1:15, but I'd like to get a few public comments, and then it sounds like at the end of that, I haven't heard any edits that the committee would like to make to this document. So after the public comments, we'll take a vote on moving this to the full committee tomorrow.
Arlen's had her hand up for a while, so you might want to let her go first.
Great, yeah, if you could help moderate, Kate.
Sure. Carlin, why don't you go ahead?
Okay, thank you. It was an early on question, high level. It's about the payback. In the payback slide, there's an estimate of 7 years and 4 years. How accurate is, for example, that 4-year payback for all electric?
Martine, can
Sure.
I ask you to answer that? I don't know if you want to see this or you want to see your PDF.
Let me see. I have mine up here. The accuracy is based on the basically the accuracy of the operational savings that are used to calculate the payback, because the incremental cost is based on the two very recent cost estimate that were done specifically for this. So the incremental cost is completely attuned to the project. The operational cost is based on basically stretch code level modeled projects that come out right now, coming out with the new stretch code at around 56. The all electric is at 50. It could be at 56, but it's at 50 because usually when we do all electric stretch code, we're able to fine tune a little bit down from natural gas in terms of the EUI. And so I don't know if that answers the question. It's based on recent energy models. The 25 is based on the project energy model and actually passive house model. Matt, you mentioned earlier, I saw on your slide that you want to see passive house. We're already doing this with Stephen Winter Associates. So we've modeled both. Great. Both the net zero all electric and the passive house all electric. So I'm hoping I answered your question. It's coming from very credible sources. They're elementary school energy models for the project and others.
Carlin, does that answer it?
Well, short of an actual numerical calculation, it'll do for now, but thank you. You're going to be trying to sell this to the public. And one of the key components for anything would be on a payback discussion, I think, is, yep. All right, what's the number and how reliable is that number? Should we believe you? That's all. Thank you.
I mean,
right. And I think, I guess my comment on that is I think we're really early on. And I guess I'm kind of surprised that SMA and Martine has clearly done a lot of work already. So I'm surprised to see these numbers, but there are a lot of assumptions baked in here right now. And I think we need to kind of get a little further into design to firm up some of the assumptions before.
Absolutely. Yes, this is, yeah, I think Matt, you have a really good point. This is feasibility level calculations. But those utility costs are based on therm usage per square foot on a similar building and therm usage and electrical use on a similar stretch code building and electrical kilowatt hour per square foot on a similar stretch code building. The EUI 25 is very easy. You do 25 kBTU per square foot per year times this project 144,000 square foot, and you transfer this in kilowatt hour, And then you use that kilowatt hour value and you multiply it by the current electrical rates. And so that's how these numbers were all calculated. So it's our best backup credible energy use and utility cost information that were used to make those numbers.
Right, but I hear you, Carlin, this will be an important focal point in the analysis.
Mhm.
Yep.
Brian has his hand up. Anybody else, if you want to make a comment, if you just put your hand up, that would be helpful.
Hi.
Brian, go ahead.
So I have a couple questions, some comments. I've been making a little sheet.
Keep them snappy, please.
I will do my best.
Great, Brian.
A quick question on the windows. I saw talk about the glazing, but the frames themselves, is there anything about thermal bridging? What windows did you look at? Because I know you can do triple pane windows, but still get the same performance as double pane if you don't stop the thermal bridging of the frame itself.
Very good question. This is based on basically assembly U value. So it's not just the glazing unit. It's the value of the glazing. So it has enhanced thermal, those triple glaze window have enhanced thermal bridging in them. The punch windows are fiberglass triple glazed, and the curtain wall is a metal frame within triple glazed.
Great.
Yeah, and sorry, and Brian, I would just say, it looks like it's pretty high level right now, where it's just kind of like a cost per square foot. So they haven't like picked a window. They're just saying, in general, this type of window costs $20 per square foot or 24.
Yeah, I just wanted to get clarification on the general specs. But the other thing was, I wanted to reinforce the value of air sealing. I know that discussion was long, but I just want to reinforce how valuable that is. As somebody who built a LEED Platinum home back 10 years ago and has operated it, I pay 10% of the utilities, just simply based on a good air seal and not being in a leaky house. To that end, I think the certification of passive house, pass or fail, is worth the effort, because if we're doing a certification, mental approach to that is, I'm going to be checked, I can't cut corners, and we get better build quality. Of course, I'm getting unstable internet. The other comment I had was on the generator. We're doing solar and potentially storage with Concord Light. Could a utility scale storage unit replace the need for that generator, that $500 million generator, and put that through the PPA, which then would lower the cost? I'll wait for that. And then the final comment would be, I know in the PDF there was a thing about $260,000 for rainwater collection and use. I didn't see that in the discussions. Could that be added to the Word doc as part of the recommendations? It's under P1.
I think that's that is a question that I've had. We didn't discuss it here, is about the water related items. So I think Matt has that captured in the Word doc as a next step to better understand.
Okay.
Yeah, just given the timeline, I'd like to exclude that one for now, because I think we want to keep it focused on energy, but that one won't be forgotten.
And a final thank you to all of you for doing this level of detail this early and getting into this and getting to the point where we're summarizing and voting on a package of these ideas to give to the bigger committee to help them move forward and show a commitment by the town to actually make a sustainable building. This is an important step. Thanks.
Great, thanks, Brian.
I saw Brad, you had your real hand up, so why don't you go next?
Yeah, just a quick question. I hope it's not too dumb. On that payback analysis, comparing the ground source and air source, they're really quite a difference. What was the relative amount of electricity use for those two systems? I assume there's there are different efficiencies in the model?
That's a really good question. Right now, because we don't have a test well right now for the site, we have to assume about the same efficiency. We haven't modeled each detailed systems, which we would do in schematic design if that's the wish. The challenge with ground source heat pump, and the reason there is quite a different, high difference in incremental cost is the test well and the wells, the cost of the wells, which for air source heat pumps, obviously you don't have them. So even with a 10% increase, let's say in efficiency, which we cannot assume right now because we really need to do this at a higher level of detail when we have a project more design and schematic design. It wouldn't move the needle, unfortunately, on those paybacks much. It's been a challenge on most of our high performance projects when we're looking at all electric. Geothermal has been a challenge because of the incremental cost. And in most cases, there is a project we're modeling right now, an elementary school that's smaller than the middle school, but still it's 80,000 square feet. And the ground source heat pump is not coming out by the time you put in, sort of the ventilation and everything, equipment, interaction, the overall efficiency is not that much better than air source heat pumps. The air source heat pumps and VRF specifically have really improved. Their efficiency have really improved over the last 10 years. So there's not a huge difference yet.
Okay.
Thanks. I don't see any other hands. Any other questions before we move on? Okay, I don't see any other hands.
Thanks, Kate. Okay, so I think if nobody has any other comments on the document, and I'll take one more pause. Nobody on the committee has any other comments.
The only thing that I would recommend is that we just add a phrase or a line somewhere that says this is a package that we feel meets the project's commitment to net zero ready. Basically that this recommendation is going to get us what we've committed to in the project charter and what the community's asked us for.
Okay. Well, I don't want to be making new stuff offline.
I trust that you can
all right.
wordsmith that.
I've got one small one. I think that we ought to be sure also that when we submit this, that we call out the air infiltration resources. We've just got to be really clear that those adequate resources will be there to ensure that we get a highly performant building with respect to air sealing.
Mm-hmm. I think that Matt's covered that pretty well.
Right. I might have tweaked it more since I sent it, Charlie. I mean, so we've got increased air sealing is critical to performance. Recommend doubling the air sealing for 160,000 total, and then I list the metric, the 0.08 CFM 75.
Yeah, I'm just talking about the testing, in-process testing related to that bullet. That's all.
I see. Okay, so I can add, yeah, great, because it's kind of lost otherwise down under commissioning, enclosure commissioning and mock-up air testing. Okay, I can add a bullet in here about
I'm all set.
okay, thank you.
Should I make a motion?
That'd be great, Kate.
So I move that the committee submit a list of recommendations to the full building committee as amended here today.
Thank you, Kate. Do I have a second?
Second.
Thank you, Frank. we need to take a roll call here. So I'm just going in order of people on my screen. Charlie,
Yes.
Frank,
Yes.
Kate,
Yes.
Russ,
Yes.
and this is Matt. I'm a yes as well. So thank you, everyone. We will move this document to the full committee for, I believe, discussion, presentation. I don't know exactly how it's going to work at tomorrow's meeting. Thank you, everyone, very much. I'm sorry we went long again, but I think it's great that we were able to produce this in the kind of compressed timeline. So
Yeah. Thank you, Matt.
thank you, everyone.
I
We'll-
move we adjourn.
Great. Thank you,
Stay
Kate.
safe.
We have movement to adjourn. Frank, that was the second.
Sure.
I'm going to go in
Yes.
order again here. Charlie,
Yes.
Frank,
Yes.
Kate,
Yes.
Russ,
Yes.
and this is Matt. I'm a yes as well. Thank you, everyone. We will see you tomorrow.
Thank you.
Bye.
Bye.
Bye, everyone. Thanks, Martine. Thanks, Mike.
You're welcome. Bye.